So in this video, we will discuss about the compound interest. I have already discussed that compound interest is for long-term investment. So for example, if you are investing $10,000 invested at 10% per annum for 5 years, so for simple interest, what you will get is first year you will get 10% on that $10,000, which is $1,000. Second year also you will get 10% on 10,000, which is 1,000. And third year, fourth year, fifth year, you will get the interest on $10,000. That is the principal amount only. So that your total amount at the end of 5 years will be 15,000. Generally, simple interest will be for shorter period of time, short-term investment it is. So we have taken 5 years just to compare with the compound interest. So here for compound interest, in the first year it is the same. You will receive interest 10% on $10,000, but in the second year you will receive 10% on 10,000 plus 1,000 what you have earned in the previous year. So therefore you will earn interest on $11,000, and the third year you will get interest on 11,000 plus the interest what you have earned in the second year, which is in total $12,100. And likewise, if you calculate for 5 years, your total amount at the end of 5 years will be 16,105.1. Right now, to calculate the compound interest using the formula, you need to know few terms here. So first one is number of compounding periods. So if the compounding periods is annually, so that means yearly once. So your number of compounding periods per year will be 1. Here, if it is semi-annually, that means yearly twice, 6 months, 6 months. So 2 times in a year, so it will be 2. Quarterly means 3 months. So 3 months means it will be 4 times in a year. So your number of compounding periods per year will be 4. Monthly means 12 times in a year. So it will be equal to 12. Daily, it is 365 times in a year. Right, so number of compounding periods per year, we denote it as M. And the annual rate or nominal rate of interest, we denote it by J. So we can calculate the periodic rate of interest, which is denoted by I. The periodic rate of interest is interest rate for one compounding period. So if you know the annual rate, and if you divide the number of compounding periods per year, so you will get the periodic rate of interest, which is the interest rate for one compounding period. So I is equal to J over M. Second thing is number of compounding periods for the period of loan. So you already know how to calculate the number of compounding periods for 1 year. Multiply it with number of years for the loan. So that will give you the number of compounding periods for the period of loan. So for all the problems of compound interest, we should we should know how to calculate I and N, that is periodic rate of interest and number of compounding periods for the period of loan. And then only we can use the formula. So let's see with examples how to calculate I and N. Loan is provided at 4% compounded semi-annually for 5 years. Identify J, M, calculate I, N. So interest rate is 4% compounded semi-annually for 5 years. So this is what is given is J, that is nominal rate of interest. So J is 4%. Your semi-annually, compounded semi-annually, so therefore it is yearly twice. So M is equal to 2. And you can calculate using the formula the periodic rate of interest, which is I is equal to J over M. That is 4 over 2, which is 2%. And N can be calculated as number of years, that is 5 years of loan. and multiply it with number of compounding period, which is 2. So 5 times 2, which is equal to 10. Now the second example is for all of you. So a loan is provided for 10 years at nominal rate at 6% per year compounded quarterly. So you need to find what is your I and what is your N. You can pause the video and try to do your own. So here 10 years at a nominal rate of 6%. So your J is 6% and your compounding period is quarterly. So we can write it as J is 6% and M is quarterly. So therefore I is 6 over 4, which is 3 over 2, and which is 1.5%. So your periodic rate of interest is 1.5%. N is for number of years multiplied by M. So you can see number of years is 10 years. So we can write N as equal to 10 times 4, which is equal to 40. So number of compounding periods for the whole term, loan term, is your 40. So next we will see how to calculate the future value. So future value can be calculated using this formula. So FV is equal to PV1 plus I exponent N. So PV is the present value or the principal amount what you have invested or you have taken the loan. I is the periodic rate of interest, and we just saw how to calculate I. And N is the number of compounding periods for the whole term, and that also we just saw how to calculate. So let's see with an example. A loan for $5,000 with interest at 7.75% compounded semi-annually is repaid after 5 years, 10 months. What is the amount of interest paid? So you need to find the compound interest here. So your loan amount is $5,000, that is PV is equal to 5,000. So the present value is equal to 5,000. Here I is equal to, or J is equal to 7.75, that is nominal rate of interest. M, that is compounding period, is semi-annually, which is 2. So we can calculate the periodic rate of interest as 7.75% over 2, and which is, if you calculate, so you will see that is equal to 0.03875. Next, we will calculate the number of compounding periods for the whole term, which is equal to, formula is years times M. So years here is 5 years and 10 months. So 5 years and 10 months we converted into years. So 5, 10 over 12, and time compounding periods is equal to 2. So we multiply it by 2. So calculating that, you will get 11.66. So this 6 is repeating, so make sure you calculate till 6 decimal place because this is an intermediate value. So substituting in the formula, you will get the future value here. So PV 1 plus I exponent n. So we can see the calculation in the calculator. So first we will calculate 1 plus I exponent n. So 1 plus I is 1 plus 0.03875, and then is equal to, we got 1 plus I and then exponent. So exponent is this one and exponent is 11.666. Make sure you consider the 6 decimal place and you will get the values. So we are following the BEDMAS rule, first bracket and then exponent and then multiplication. So multiply it with 5,000. So you should get this as 7791.0995. So rounding till 2 decimal place, it will be 10. So rounding till 2 decimal place, we got the future value as 7791.10, and future value minus present value, you will get that how much interest was paid for this loan, which is 2791.10. Right, so the second example is for you to calculate a debt of $3,500 dated August 31st, 2016 is payable together with interest at 9% per annum, compounded quarterly on June 30, 2019. Determine the amount to be paid. So we can write the present value as 3,500. I, that is periodic rate of interest, is equal to nominal rate of interest over number of compounding periods per year, that is J divided by M. And nominal rate of interest is 9%, and because it is compounded quarterly, so divided by 4, which is equal to your 2.25%, and which is 0.0225. Right, next is your N. So for that, we have the formula years multiplied by M, and we can calculate the number of years as August 31st, 2016 to June 30, 2019. So we can write here August 31st, 2016 to June 30, 2019. So we need to count the number of years and months. So here you can see from 2016 August to 2018 August, we have 2 years. So we can write 2 years here, and then we have number of months. So September, October, November, December. So 4 months in 2018 and remaining 6 months in June. So 4 and 6, that is 10 months in this one. So 2 years and 10 months. So we can write here the number of years is 2 years and 10 months, and multiply it by number of compounding periods, which is 4. So it is your 34 over 12 times 4, 11.333333. So we can substitute in the formula that future value is equal to present value 1 plus I exponent n. So present value is your 3500 and then 1.0225 as your I, and n is 11.333. Make sure you consider till 6 decimal place. So we have to apply the BEDMAS rule. So first bracket and then exponent. So we will calculate this exponent and multiply it with 3500. So calculate your own and see what answer you are getting. So next example on future value is a deposit of $5,000 earns interest at 7% compounded quarterly for 4 years. At that time, the interest rate changes to 6% compounded monthly. What is the value of the deposit 3 years after the change in the rate of interest? So $5,000 is the present value. Your J is 7% quarterly for 4 years. And then after 4 years, it got changed to 6% compounded monthly. So then you have to find what is the deposit, what will be the future value 3 years after the change in the rate of interest. So we can say that what it is showing is this one, and you invested here as $5,000, and you can see that for first 4 years it is 7% and quarterly. And then next 3 years, because you have to find 3 years after the deposit, what will be the 3 years after the change, what will be the value here. So, and the change is 6%, which is monthly. Right, so the problem will be solved in two stages. In the first stage, your present value will be 5,000 and your J is 7%. Your compounding period is quarterly, which is 4. So I is 7 over 4. You can calculate. N is number of years times the compounding period. The number of years is 4 and times compounding period is also quarterly, which is year 4. Right, and you will can substitute in the formula of future value to calculate what is the future value here. And in the second step, this future value will become the present value for the second one because you invested here $5,000 and you received here the future value of the first stage. Now again you will reinvest it for another years at this rate. So that will become your present value. Your J is 6% here. Your M is monthly, which is 12 times in a year. Your I is 6 over 12. So that is your 0.5%. And N is number of years. So for 3 years you have to use and then multiply it by 12. So multiply it by 12. So 36 is the N value. So you need to substitute again in the formula of future value to calculate what is the future value after 3 years of the change in the rate of interest. Right? So now you can pause the video, try to do your own and see whether you are getting the same result or not. In the first stage, you will get the value as 6599.64 6756. Make sure you consider it for 6 decimal place because this is your intermediate value. All the intermediate values should be considered till 6 decimal place. And that becomes your present value here and calculated I and N and substitute in the future value formula. So you should get the future value as 7,897.67. To calculate the present value, we'll use the same formula the other way around. So PV is equal to FV 1 plus I exponent negative n, where I, n has its usual meaning. Periodic rate of interest is I, n is number of compounding period for the whole term. FV is the future value. So let's see an example. Calculate the principal that will amount to $10,000 in 6 years at 4% compounded quarterly. So principal amount you need to calculate, which will become $10,000. So future value is $10,000. I is 4% compounded quarterly, that is 4 over 4, and N is 6 years compounded quarterly, that is N is equal to 6 times 4, which is 24. So we can use this formula, substitute in the formula and calculate. So you will see that your present value is 7,875.66. That is, if you are investing $7,875 for 6 years at this rate, so you will get $10,000 after 6 years. So let's see in the calculator how to calculate this one. So we'll follow the BEDMAS rule. 1.01 exponent, and we'll use bracket after that, negative 24. So bracket close. So we get the exponent first calculated and then multiply it with your future value, so which is 10,000 given here. So we get $10,000 multiplied, and you will get 7,875.66, rounding till 2 decimal place. So next, one application problem on present value. So you have the choice of receiving $100,000 now, or $60,000 now and another $60,000 in 5 years from now. In terms of today's dollar, which choice is better and by how much? Money is worth 6% compounded annually. So you have been given two options. In first option, the $100,000 now. So it is already calculated in present time. In second option, $60,000 now and another 60,000 in 5 years from now. So this is already given in today's time, but the second 60,000 is given in future. So you have to know what is the value of this 60,000 in current time. So this will be future value. Your I, you can calculate 6% annually, that is 6 divided by 1. And you can find the N, that is 5 years. So 5 years compounded annually. So 5 times 1 is equal to 5. And you can substitute in the formula to find the present value. So 6,001.06 exponent -5. So you will get 44,835. So in the second option, total he will receive is 60,000 plus 44,835. Together it is 104,835. So of course it is a choice of receiving. So you want to receive more. So more you receive is better. So 104,000 is more than 100,000. So therefore you will choose the second option. So this completes all the topics of future value and present value of compound interest. You can do more practice problems based on the compound interest.